Yeah, you're on Jill level now.
All right, you ready? Here we go.
Oh, no.
Switch from degree mode to radians. We will be going back and forth between the two a little bit later, but for right now, this whole page is in radians. So right now we need you in radians. If you look at this little chart in the top left corner, it's the exact same chart that you have from same signs, different signs that you were just using on their quiz, this one. From same signs but different signs. It's the exact same chart except this one is in degrees and the new one that you got today is in radians. The rules don't change. So you saw on your quiz, if you're looking for angles, remember your calculator only knows how to give you one angle. It doesn't know what quadrant you're in. It doesn't know what your triangle looks like. You're the only one that knows that. So you have to follow the rules to find the other angles that are available. How many angles are possible at a certain place? Or with, like, for example, this cosine of alpha is 0.54. How many angles possibly have cosine of 0.54?
I'm gonna get my stuff.
How many are there possible?
Just kidding.
How many are there that are possible at that place? There are infinitely many. Because remember, I can take these are rotation angles we're talking about. So this angle right here, if I swing all the way around the circle and come right back to here, that's technically a different angle, but it would have the exact same cosine. And I could go all the way around again. Or I could go around in the negative direction, and they have the exact same cosine. So because of that, they give you an interval, like on the test, on the quiz, it gives you an interval of 0 to 360. Otherwise, you'd be sitting there all day writing down angles for that cosine, because there are infinitely many. So real quick, we're gonna solve one in radians. So it says right over here, cosine of alpha is 0.54. I want my alpha by itself. So what am I going to do to alpha by itself in this case?
Inverse cosine?
Inverse cosine. So I'm going to inverse cosine the left-hand side. That means I also have to inverse cosine the right. That cancels cosine, gives me just alpha. So I'm going to put in my calculator inverse cosine of 0.54. And it gives me 1, approximately 1, 1.00035. So approximately 1. Now that's just one answer, and that's in radians, because I switched to radians because it told me to. But there are so many answers that are that same one. The rule for cosine is that you can put it in your calculator, do inverse cosine, that's the first step. And if that's not the angle you need, you can add 2 pi n. The n means however many times. So right over here, there's the 1 plus 2 pi. There's 1 plus 4 pi, because that would be 2 pi again. You know, 2 pi, and then go around again, that's 4 pi. Go around again, that's 6 pi, and so on and so on and so on. Because they didn't give me an interval to stop. The other thing you can do for cosine, and this only works for cosine, is you can take what the calculator gave you, and you can make it negative, and then add 2 pi. And 4 pi. And so that's what they're doing right here. Negative 1 plus 2 pi plus 4 pi plus 6 pi. So now, the reason why we give you an interval is so that you stop and you don't end up with 9,000 angles. So in this case, on this particular page, they wanted us to go from 0 to 2 pi. I know that this page is in radians, but if I didn't know, that would be my indication, because the interval is given in radians. If it says 0 to 360, I know I'm in degrees, but this says 0 to 2 pi. That's one trip around the coordinate grid, from 0 to 2 pi. Go all the way around once. So I need to get theta by itself in this first one. So how do I get rid of sine?
Inverse sine.
Inverse sine, or arc sine. So I'm going to inverse sine the left, which means I also have to inverse sine the right. That cancels the sign on the left. And when I do inverse sine of 0.4, I get 0.411. Oh, I forgot to ask this. So in your calculator, all of these, this is why they're nasty decimals, the pi has already been multiplied through. So it's not going to be the nice ones that are fractions like pi over 3 and pi over 8 and stuff. The pi's already been multiplied through. So because of that, I need to know, so that I'm sure about my interval, what is 2 pi as a decimal?
270, right?
2 pi as a
Not as a degree. What is 2 pi as a decimal?
Oh.
6.28. So when I'm looking at my values that the calculator gets me, I need to make sure that I'm between 0 and 6.28. That's 0 and 2 pi. This is 0.4115 or 0.412. That is between 0 and 2 pi. But the instructions say I need 2 of them, not just the first one. So I go up to my chart and I follow the rules for sine. The first thing I did was inverse sine. That's where my first angle came from. The next thing you can do is you do pi minus what the calculator gave you. So I'm going to do pi minus 0.4115. If you will always just go up and grab it like that, then your rounding won't be off when you're doing delta math. 2.73 is my other. Is that on the interval of 0 to 6.28? It is. So that's my other angle. Are y'all okay?
Oh, that's
Understand following, like going up to the chart and figuring out which thing you're going to do. You will have to know the chart, but you're going to use it enough. I think you'll probably just know it anyway. But all right, tangent of theta equals 2. So I need to get rid of tan and end up with theta by itself. So I'm going to arc tangent to get rid of tangent, which means I have to arc tangent the other side. Arc tangent of 2.
Can't you inverse cosine, like flip the sign?
Cosine's the only one you could do that with.
Okay, that's what I thought.
So I get theta is 1.11. That is on my interval, but I need another one. So the rules for tangent is the calculator's going to give you 1, and your other option is to either add or subtract pi. So if I subtracted pi, I'm going to be in a negative, so I'm just going to add pi. And that gives me 4.248 or 4.25, which is also on your interval.
Isn't secant cosine?
Yeah.
Or I guess 4.
So cosine of theta, I need to get theta by itself. Arc cosine or inverse cosine. So inverse cosine of 0.5.
So this is my last day of school. What? I'm just kidding.
All right, so I get 1.05. Now the rule for cosine is, if you look, it's add 2 pi. Well, if I add 2 pi to 1.05, it's going to be too big. But the other thing that you can do with cosine, and it's the only one you can do this with, is make it negative. So I'm going to hit a negative sign, go up and grab that value, and then add 2 pi. And that 5.24, and that's in my interval.
Well, wouldn't you just add the negative sign to the 1 with that negative? And just make it negative 1.05? Oh.
All right, are y'all okay? All right. Then I got secant. You're okay.
Do you still have those like little delta maths that you used to do?
Yeah, there's one in there actually right now.
Okay.
It's open. So you remember you have to go in through,
Like the website.
or not, don't go through the website, but go through the side. Yeah.
Okay.
When you go
I
into.
haven't been able to make fun of
It's
it
on the
for
side.
2 weeks.
Yeah, you're like, it's been too long.
Okay, so secant is buddies with cosine. So I can change this to cosine theta, and that means I'm going to flip over my fraction because they are reciprocal partners. So, and then I can arc cosine.
Oh, I did.
Because I don't have a secant button on my calculator.
Oh,
So in order to be able to put it in my calculator, I flip it to make it its buddy.
You're finding the square root when you just put 1 over square
Mhm.
root 2. Okay. Sorry, I'm kind of looking
You're good.
ahead, but.
So arc cosine of 7 over 9 is 0.68. secant follows the same rules as cosine, so I can make this negative and add 2 pi. So 5.6. So again, cosecant, I'm trying to get theta by itself. There's no cosecant button on my calculator, which means there's no arc cosecant button. So I'm going to rewrite cosecant as sine, because they're reciprocal partners. So this would be sine of theta equals, I just flipped this over, so it's going to be 1 over the square root of 2. Do not worry about rationalizing this, because this isn't your final answer. The calculator will take 1 over the square root of 2 just fine.
Why won't you take it?
Because it's not my call, it's a math rule, the laws of math.
But who made that?
Oh, but they
I don't know.
calculator just.
Are they dead?
I don't think you're dead.
So I can go find them and argue with them.
You could, what do you?
Technically, the
So,
calculator is smarter than people.
1 over,
I just realized I'm committing 2 crimes against these.
I got 0.75,
What?
0.785, sorry. So 0.79. Okay, so that's the first one. So for sine, the rule is 1 or pi minus that number. As long as that stays on the interval, which it does, so 2.36. There's no cotangent button on your calculator, so we're going to switch it to tangent. Going to do 1 over the square root of 3. We have to arc tangent that. Point 5.2. The rule for tangent is to add or subtract pi. So I'm just going to add pi to that. That should be on the interval still. 3.67. All right. So far so good? This part, that was pretty easy, right? Everybody's clear on how you use the chart?
Yes.
All right. So what if they had told me that I wanted to go on the interval of 0 to 4 pi? What would you have done to some of those things? What if they had told me they wanted me to go on the interval of 0 to 4 pi instead of just 0 to 2 pi?
When you have had like more answers.
You would have had more answers. You would have twice as many, because 4 pi would be another trip around the circle. So you would just keep adding 360 or keep adding 180 or whatever it is the rule is. You just keep doing it until you've gone all the way around your
So
interval.
you just add 1 to every one, or add like up like 3 points.
You would add whatever. So if it was a sine one, you would add 2 pi because that's what it tells you you can add. If it was a tangent one, you add pi because that's what tangent one you add. But sine and cosine is both 2 pi. Okay.
Debbie, I need you to put footing something.
All right. So some of these pi has been multiplied through in your calculator, but some of these actually have exact answers. So, but you can't tell it because pi's already been multiplied through. So I need you to real quick tell me what these are as decimals. What is pi over 3 as a decimal?
1.04.
It's whatever pi is divided by 3.
Yeah. So what is it?
You're a genius.
1.04.
What is it?
1.04.
1.04?
See that.
Yeah.
It's like 1.047, right?
Yeah.
I still can't do that.
I was
Okay.
hoping you would see that.
Oh, yeah.
Okay, so it as a decimal, pi over 3 is 1.047. Which equation that we used up here has that?
Oh.
Which problem?
Couldn't it be problem?
Problem number 3. I rounded to 1.05, but that's it. So that's number 3. All right, what about pi over 4? What is it as a decimal?
0.785, which would be
0.785 or 0.79, which was number
5.
5. And then what about pi divided by 6?
0.523.
0.523, which is number 6. All right, so on those, if you look at what the original problem had in it, number 3, the cosine theta is actually 0.5 or 1/2. On number 5, it was square root of 2. Oh, we'll go back to this part. It was square root of 2. And on number, what was this? I didn't even write the number down.
6.
Number 6, it was square root of 3. All right, so 1, 2, square root of 2, 3. Do those numbers sound familiar to anybody for any reason?
Yeah.
Why are these values special?
Because you can multiply them by like 180 or something, you get the degree.
Oh, that's good thought. They're special because they come from special right triangles.
I'm special because I came from my ancestors.
So, if you remember, a 30, 60, 90 has legs of 1, square root of 3, and a hypotenuse of 2. And a 45, 45, 90 has legs of 1 and 1, and the hypotenuse is square root of 2. So these values are special because they come from special right triangles. And if they come from special right triangles, what that means is we can find their exact answer and not have these decimal answers because we don't like decimal answers. We want exact answers. Exact answers are more meaningful.
You don't want them to be exact.
If we don't want them to be exact, then we'll use the calculator and we'll get decimal answers. But most of the time in pre-cal, we're looking for exact answers. So keep that page because you're going to need that little chart. Probably need it on your quiz tomorrow until you have it memorized.
I don't think I'm ever gonna have those memorized.
You won't.
Oh my god, your eyeballs are ready. Go back to sleep. His whole white of his eyeballs turn really red.
So
So if it makes you feel any better, cosine's the only one that can flip.
What's going on?
Good sign.
I got that.
Oh,
Oh wait, never mind.
Okay.
My bad.
Hi.
I was like, you only give me 2.
All right. So here we go. We are going to figure out how to find the special values without a calculator because we don't want decimal answers. We want exact values. So they say that it's as easy as QRST. If you can remember, these are the steps, QRST. The first thing we're going to do is figure out what quadrant the rotation angle will terminate in. So on sample A, I'm looking at a 300-degree angle. Where would that terminate? Quadrant 4. So 300 degrees, that would go all the way around here and somewhere around here. 300 degrees. Terminates in quadrant 4. What is my reference angle for a 300-degree angle?
60.
60. So that's what would be the remaining piece. So we can draw a triangle, a right triangle, by drawing back to the x-axis, just like we always have. Always back to the x-axis, never to the y. And this is a 30, 60, 90. Well, across from the 60-degree angle is the long leg, which is square root of 3. The hypotenuse is 2, and the short leg is 1. So now, in reference to the 60-degree angle, so this is 1, square root of 3, and 2 are your sides. In reference to the 60-degree angle, because I'm using my reference angle, what would sine be? I know it says sine of 300, but we use our reference angle. So sine of 60, what is sine? Which pieces?
Oh,
Opposite over hypotenuse. So if you look at your 60, what is opposite of the 60? Square root of 3, and your hypotenuse? 2. Now the only other thing is, I am in quadrant 4. What is positive in quadrant 4?
Huh?
What's positive in quadrant 4?
Cosine.
Just cosine. So my sine value should be negative.
I did not remember that.
What?
Hey, you know, I thought in ISS I would be free from that loser's voice. No, his voice was louder than yours.
Oh, on the video.
really? You can hear her?
Okay. All right, let's try another one. QRST. This was in radians.
One day she got us bad. We were talking about some like not good
Where
stuff.
is negative
That was
5?
the best day of ISS I've ever had.
So I'm recording right now. So where is negative 5 pi over 4? What quadrant is negative 5 pi over 4 in?
Why you have to do this here?
No.
5 pi.
It's in 2. because it's negative, it's going backwards.
Yeah.
So this would be 4 pi over 4, so negative 5 pi over 4 is over here somewhere. So it's in quadrant 2. Just, it doesn't matter. As long as it didn't say it has to be positive, you can just leave it. So the reference angle is going to be pi over 4 because this is in radians, and that's all you have to do is it has to have the same denominator. So pi over 4, that's a 45-degree angle. All of the ones that have a 4 on bottom are a 45, which means it's a special right triangle. If I build this triangle, it has legs of 1 and a hypotenuse of square root of 2.
How do you know that, how are they both one, like on the side?
Because it's isosceles.
So why wouldn't the other one be like a 2?
Because it's a 30, 60, 90, but this is a 45, 45, 90.
Is this all the-
So,
Okay.
so the two angles are the same, which means the two sides are the same.
Okay.
All right, so secant. Secant is buddies with which one? It's reciprocal buddies with
Cosine.
cosine, and cosine is what, two pieces of the triangle?
Hypotenuse and adjacent over hypotenuse.
It's adjacent over hypotenuse, which means secant is hypotenuse over adjacent, which means
You gotta flip them like.
you got, so hypotenuse is square root of 2, adjacent is 1, so I can just do square root of 2. Now, down here it's asking me to find all of the values, all of the trig values for this angle. I'm going to put a B right here because it says simple B. So, sine, opposite over hypotenuse. So that would be 1 over, oh, I got to, secant isn't positive in this quadrant, it's negative, sorry. Okay, sine is 1 over square root of 2. Can you leave it like that? No. Nope, got to rationalize. So multiply both the top and the bottom by square root of 2, and that's going to give you square root of 2 over 2. Sine is positive in quadrant 2, so it's positive square root of 2 over 2. Cosine is adjacent over hypotenuse, so that is also 1 over the square root of 2. You can't leave it like that. Got to rationalize. So multiply both the top and the bottom by square root of 2 over 2. That's going to give me square root of 2 over 2, but cosine is negative in quadrant 2, so it's going to be negative. Tangent, opposite over adjacent. So it's 1, but tangent's negative in quadrant 2. Cotangent is just tangent flipped over. What is negative 1 flipped over?
Flipped over.
Still negative 1. Secant, we already did that one. That was the one we did to start with. It's negative square root of 2. Cosecant is sine flipped over. So if I flip over what's in green, because I don't want to have to re-rationalize whatever. If I flip over what's in green, that's square root of 2 over 1, which is just square root of 2. That's all the pieces. Are we all over?
Are we gonna go and start on the back?
Yep. All right. On back. So, in this case, 3 pi over 2. Where is 3 pi over 2?
It's on the graph.
It is on the graph. Where on the graph? Y-axis. Where? Bottom. It's at the bottom. 3 pi over 2 is down here. So it's on the y-axis.
Yeah, I told you it was on the graph.
Logan, why put this up?
So you cannot draw a reference triangle. When it is on one of the axes, it's not possible. But that's okay because we can just use the ordered pair. So remember we talked about this the other day. If we have, if I have an angle and I have the arm that's swinging around has a radius of 1. Then when I swing this open and up at the top, the ordered pair that's up here at the top is going to be the ordered pair 0, 1. So that's how you would get to that dot. This way would be negative 1, 0. Down. I did not say you guys could leave.
Trying to get Logan
Ugh!
You
Just tell him I'm going to write him up because I didn't go. Just tell him I'm writing him up because he didn't ask me to leave today. Down, because I'm still talking. So
Yeah, I was like, I can't believe you just walked out. And
Yeah,
I mean, I was like, what?
So straight down is the ordered pair 0, negative 1. And to the side is the ordered pair 1, 0. So that's what really matters. And so if we're down here, It's the ordered pair 0, -1, and the radius is 1.
Why is the radius?
Because that's what I did was I took a radius of 1 and swung it around. That's how I got mine. I could have used 3. But if I use 3, radius of 3, that means the order pair down here would be the order pair 0, -3.
Okay,
So however long the radius
So
is.
it's literally
Does it have
just,
to be an
you
odd
just
number?
flip it all the way around?
No, it could be whatever.
Oh.
It could be anything. But 1's just easy. So that's why we're going to use
Well,
1.
you went from 1 to 3, so I didn't know if it.
Oh, yeah.
So you can literally just use what?
Whatever. But 1 is the easiest value, so that's what I'm going to use. So remember, the ordered pair, I know that we're used to opposite over hypotenuse, but remember when we first started this rotation angle thing, that it's also y over r. So when you're using with quadrantal angles, I'm going to use that. Y over r is negative 1 over 1, which is just -1. So 3 pi over 2 is -1. Sine is y over r, cosine is x over r, and tangent is y over x. So they want me to figure out all of the other angles here if I were to stop on all of the quadrantal angles. So first of all, they didn't fill these in, but we're doing it in both radians and degrees. 0 radians is also 0 degrees. And so this ordered pair over here is the ordered pair 1, 0. Sine is y over r. So that would be 0 over 1, which is 0. Cosine is x over r. So that's 1 over 1, which is 1. Tangent is y over x. 0 over 1 is 0. Cotangent is tangent flipped over. So tangent was 0 over 1. Cotangent would be 1 over 0. What's the problem with that?
You can't divide by 0.
You can't divide by 0. So cotangent at that place is undefined. And in a week or two, you'll see why that it's undefined. Secant is cosine flipped over, so it's still 1. All right, we will start there tomorrow.
Ms. Brandon?
Yep.
Can you, I don't know if it's I retake that quiz.
Today's?
Yeah.
Yeah.
Can I come in tomorrow during 8th period?